Okay, this is just to remind you that there are 7 elements on the periodic table that only exist as diatomic molecules, which means they only exist in pairs. For example, copper is not a diatomic element, therefore copper can exist alone. However, if I were to state that you have hydrogen gas present, for example, hydrogen could not be written as just H because it is a diatomic substance. It has to be H2. It only comes in pairs when it's neutral. So be careful because we're talking about neutral molecules here, and when it comes to ions, the name is what is going to tell you whether or not it's neutral or an ion. If it ends in "ide," then it would not be F2, for example. That would be F to the -1, because fluoride is an ion, F to the -1. Fluorine, however, is a neutral molecule and therefore, and also diatomic, therefore it would be written F2. So just so you can see an example of, say, one of the diatomics used in 4 different ways, remember it's only diatomic if it's alone. So here we have bromine in every single one of these examples, but you're going to see where it's a completely different naming scenario. The first one is an acid, and because it's hydrobromic acid, that means that our root is bromide, and so the acid will be hydrogen plus 1, Br minus 1, which gives me a final formula of HBr. Bromine is neutral, so it's going to be Br, and because bromine is diatomic, it's going to also get a little 2. Calcium bromide is ionic, so because this one is ionic, we have to use charges. They either cancel or switch. Calcium is plus 2, bromide is Br minus 1, so I'm going to switch the charges and have a ratio of 1 calcium to 2 bromines. Finally, carbon tetrabromide is covalent, and so we're using the prefixes to tell the name. We have 1 carbon, we have 4 bromines, and so this would be written as 1 carbon and bromine with a little 4 next to it to show that I have 4 bromines. So again, 4 very different ways using one similar element. 4 different naming rules.